आज पावर इलेक्ट्रॉनिक्स की लाइव लेक्चर सीरीज की शुरुआत हो रही है। ये मैं अपने HBTU के स्टूडेंट्स और साथ ही साथ पावर इलेक्ट्रॉनिक्स पढ़ने वाले सभी छात्र छात्राओं के लिए लाइव प्रसारण किया जा रहा है। आई एम प्रोफेसर संजीव कुमार, वर्किंग एट HBTU Kanpur in electrical engineering department. In very first lecture, we will start with Thyristor, right? So, in Thyristor, it was invented in 1957 and it can handle the voltage up to, you can say, 10 kV, and the rating which it can handle is 3000 ampere, and the power rating is somewhere around 30 megawatt. So you can imagine how powerful power electronics device it is. This Thyristor constructional block diagram, in fact constructional details is shown in this figure. You can see anode is made of aluminum and this is having two PN junction. This PN junction J1 and this NP junction J2, and then with cathode it is forming another junction J3. So overall it is having three junctions J1, J2, J3 and four layer of PN semiconductor material PN, PN, right? So it is the schematic diagram. This figure, it is having three terminal, anode, cathode and gate, and it is having three junction J1, J2 and J3, J1, J2 and J3. And this is the circuit symbol, means in the circuit you can see like this: anode, cathode and gate. So this is the basic symbol as well as circuit and constructional diagram of Thyristor. Now we will see the how we can put it in the circuit. This anode to cathode is supplied by some supply. It could be AC or DC. At present it is DC is shown, and a load is connected in series with the Thyristor. So whenever this Thyristor gets turned on by applying the gate pulse, this voltage would appear across the load and current will flow like this. So you can control the flow of current in this load depending upon whether this switch is on or off. You can see this Thyristor is like switch. Whenever it is on, it will allow to flow the current, and whenever it is off, it will not allow to flow the current. So it is operating as switch. Either it could be on or it could be off, right? And we apply the control signal, which is the gate pulse, here between the gate and cathode. So control signal is applied between the gate and cathode, and power circuit or the power which is flowing via this load in the form of its current is through the load and Thyristor, that is applied at the between the anode and cathode. Means एनोड और कैथोड के बीच में आपको एक सप्लाई लगा देनी है, और उसके बाद जब भी आप गेट पल्स देंगे तो आपका थायरिस्टर ऑन हो जाएगा। एक बार थायरिस्टर ऑन हो गया तो फिर गेट का कोई भी उसमें रोल नहीं रह जाता है। आने वाले लेक्चर्स में हम लोग इस चीज को देखेंगे, समझेंगे और जानेंगे। नाउ कम टू द VI characteristic of the thyristor. All this figure I have taken from the PS Bimra, so easily you will get all this thing in that particular book, right? And I will appreciate if simultaneously you will draw these circuit on your notebook as well, right? क्योंकि आज के सब बच्चे वीडियो पे ही देख करके पढ़ना चाहते हैं, वीडियो पे देख करके पढ़ाई नहीं होती है, ये सिर्फ आपको दिखाया जा रहा है। जब तक आप अपने नोट्स नहीं बनाएंगे आपके मतलब का कोई भी लेक्चर नहीं है। ये सारी बातें जो मैं आपको बताने जा रहा हूं ये सब कुछ हर बुक में हर जगह अवेलेबल है, राइट? तो ओके, विदाउट वेस्टिंग मच टाइम, लेट अस स्टार्ट दिस voltage which I'll call, let me increase the width. Okay, fine. So this voltage VA, this is the voltage which is applied by the supply, and the voltage which is appear between anode and cathode is known as VA. So this voltage is VA. Mind it is not the applied voltage, it is the voltage which is appearing between anode and cathode, right? As simple as that. Let me also draw this. So this is the voltage VA, and this is the anode current IA. This I am showing here. Make this symbol is small. This is the anode current IA, right? Although I am see, generally the variable quantity has to be shown in a small letter. I mean it has to be shown like this, VA, and this is a small VA, right? So it is IA, and this is let me just IA, and this is VA. So the thyristor characteristic means, static VI characteristic means you are drawing the waveform between voltage and current. Voltage across the anode to cathode means voltage between the anode to cathode, and current flowing from anode to cathode. So you can see it is the typical VI characteristic of the thyristor. This the basic mode of operation is, the first one is this forward blocking stage. This is forward blocking stage. Rather than making it, I am just underlying this. This is the forward blocking state. Means what? Thyristor voltage between anode and cathode is positive, and small leakage current is only flowing. Thyristor is not in on state, but it is in the state, mean when you apply the gate pulse it will get on, right? So that is the forward blocking state, and this is the off state. चल नहीं रहा भाई मेरे, चल नहीं रहा है, right? This is called reverse blocking state, means you applied negative voltage. Anode you have put negative and cathode you have positive. That is the reverse blocking mode. And the third state is when it is in forward conduction state. This forward conduction state means thyristor is turned on. The current flowing through this is VDC by R, means VDC you have applied the voltage and R is the load resistance. So that much current is flowing. Like if it is like R and this is VDC, so during on state IA would be VDC by R, right? That will be the flow of current, that is known as on state. Clear? Now see what happened when you don't apply gate pulse, means Ig is 0 and you keep on increasing the anode to cathode voltage. You keep on increasing the anode to cathode voltage. So basically what happening, you just see, it is like this, it is like this. This is your junction J1, this is your junction J2, this is your junction J3. If you applied positive voltage here and this terminal is either 0 or negative, so let us make it 0. That means voltage is dropping from here to here. This is P, this is N, this is P, this is N. Let us just assume, right? ये वोल्टेज 50 है, थोड़ा ड्रॉप हुआ तो ये हो गया 35. Now further this voltage is drop, so it is, let us say, 25 and here it is 0. Whenever you have to check whether device is in forward bias or reverse bias, what you have to do, you simply anode voltage minus cathode voltage, right? This you have to do, anode voltage minus cathode voltage. Clear? So anode is, let me take different color pen. Anode is 50, cathode is, N is at 35, so 50 minus 35 equal to 15, so positive. Very good. J1 is okay. Now come to the junction J3. P is 25, N is 0, so it is again positive, so J3 is also okay. Now check the junction J2. This junction J2. P is 25, P is at 25 volt, N is at 35, N is cathode. So now it is come out to be minus 10, which is negative. So junction J2 is in reverse bias, right? So during forward blocking stage, your junction J1 and J3 are in forward bias, whereas junction J2 is in reverse bias. So what you will do? Let us wait. Now if you keep on increasing the voltage, a level come when this voltage reaches to VBO. VBO is breakover voltage. At this, your junction J2 is break, and current start flowing. We generally avoid this. We should not reach up to breakover voltage. What we do, we just control the conduction of thyristor by applying the gate pulse. If we apply gate pulse, and here you can see the gate pulse value, means gate current Ig3 is greater than the Ig2 and Ig2 is greater than the Ig1, means as you keep on increasing the gate current, thyristor get trigger earlier than the breakover voltage. Here thyristor is trigger here and immediately it get on. So here two currents come in the picture. One is latching current, other one is holding current. The latching current, it is the minimum value of anode to cathode current which must be attained by the thyristor before removing the gate pulse. ध्यान से मेरी बात को समझिएगा. गेट पल्स को हटाने से, जस्ट हटाने से पहले, जिस क्षण आप हटा रहे हैं उस समय थायरिस्टर को लैचिंग करंट के बराबर वैल्यू प्राप्त कर लेनी चाहिए. इट मस्ट अटेन द वैल्यू at this point is latching current, and this latching current and holding current is provided by the manufacturer. They provide it in the data sheet, right? They provide it in the data sheet. So if you wish your thyristor should get on by applying the gate pulse. तो gate pulse का duration साहब इतना होना चाहिए कि उतनी देर में, जितनी देर में आप gate pulse दे रहे हैं, उतनी देर में thyristor latching current की value प्राप्त कर ले. Once it attains the latching current, immediately it will get turned on, and the value it will attain, that is the infinite current. Here the meaning of infinite current is cathode voltage. What happened? What happened? Anode to, if you decrease anode to cathode voltage, anode current get decreased because it is equal to VDC by R. Now anode to cathode current decrease, and a moment come when this current reach up to this value. This value. That means the holding current. If you further decrease the current, your thyristor get turned off. Means it is the value of anode to cathode current below which your thyristor get turned off, that is known as holding current. The value of holding current is always less than the latching current. And one thing you should always remember, latching current is associated with turn on process and holding current is associated with turn off process. Clear? I hope it is clear. Now likewise, if you apply negative voltage, means cathode is positive and anode is negative, then reverse leakage current is flowing. And a moment come when your junction J1 J3 get break out. Means जब नेगेटिव वोल्टेज अप्लाई करा बॉस तो क्या हुआ होगा, आपका जो जंक्शन J1 और J3 है वो तो रिवर्स बायस में होगा और J2 फॉरवर्ड बायस में होगा. सो J2 तो फॉरवर्ड है, J1 J3 रिवर्स है. लेकिन अगर आप इफ यू कीप ऑन इंक्रीजिंग द वोल्टेज, अ लेवल कम एट विच junction J1 and J2 suffer from the avalanche. An avalanche breakdown occur at junction J1 J3, and what happened, your thyristor get it maybe get damaged. So you should not apply the reverse voltage, right? Because J1 and J3 suffer from the avalanche voltage breakdown, and huge amount of current is start to flowing. And this huge amount is what? It is simply again VDC by R, because the circuit is, your thyristor get short circuited, right? So this is all about the VI characteristic. Now the next thing which I would like to tell in this lecture is two-transistor model of the thyristor. Right, let me change the color of the pen. Okay, this two-transistor model I am going to draw for you. Just give me a second. So in this, what happened? See, this we can say thyristor is having three junction like this. So this is let me make it like this. Now what I am going to do, I simply cut, just only for understanding. It is not like that I am going to cut this into two parts. I just do it like this. Now see what happens. If I consider like this, now it is become two transistor connected in this fashion. One is P and P, and other one is NP and, right? So it would be like this. Now I am again drawing this I am again drawing this. This is one transistor, it is another transistor. So if you look at this, you can notice, what you will notice? You can notice the collector current of transistor 2. The collector current of transistor 2 is the base current of transistor 1, whereas the collector current of transistor 1 is the base current of transistor 2. ये जो इसकी कलेक्टर की करंट है इसके लिए बेस करंट का काम कर रही है, और जो इसकी बेस करंट है भाई दूसरे वाले ट्रांजिस्टर के लिए कलेक्टर करंट का काम कर रही है। और ये पूरा ब्लॉक हमारा थायरिस्टर का है जिसमें ये करंट क्या है Ig, दिस इज द गेट करंट, दिस इज द एनोड करंट एंड दिस इज द कैथोड करंट, isn't it? Now just redraw the circuit. Just redraw the circuit. Now I have clear cut figure of this transistor, and you can see, let me reduce the width of, and you just see this is one transistor, this is one transistor, right? And it is like this, it is like this. This is your IA, this is your IA current, this is your IA, and this is your IC1, right? This is your base current of 1 IB1, which eventually become collector current of IC2, right? Similarly, this is your IC2, this is your IC2, because this is NPN type, whereas transistor Q1, this is Q2, Q2 is NP and Q1 is PNP, right? It is like this. Now if you look at closely, we already know that this alpha 1, we can write the collector current in terms of its leakage current, and ammeter current. How we can write this? We can write it like this. IC1 is equal to, let me take the marker, IC1 is equal to alpha 1 IA plus ICB01, because we know in general IC is equal to alpha E plus ICBO, where ICBO is the leakage current flowing, right? ICB is leakage current, so it can be written like this. ICBO is common base leakage current of Q1 and alpha 1 is common base current gain of Q1. So we can write it like this. Let us make this equation number 1. Clear? Similarly, we can write it for transistor 2. It could be written as IC2 is equal to alpha 2 IK plus ICB02. Here IK is the ammeter current of the transistor 2, which eventually is equal to the cathode current, right? So in that way it can be considered like this. IC2 is equal to alpha 2 IK plus ICBO, because IK is what? IK is the emitter current. IK is IE for this transistor 2, right? So we have these two equations. Now we know when the gate current is 0. Gate current is 0. See what happened? This this transistor current, that is IC2, and this current IC1, that is coming here. So IA is equal to IC1 plus IC2 when gate current is absent. When gate current is absent. Fine. Now we have put the value of IC1 and IC2, which is equal to alpha 1 IA plus ICB01, and current value of IC2 is alpha 2 IK plus ICB02. And we also know that cathode current is equal to anode current plus gate current. Look at this. This is the cathode current. This is the cathode current. This is what? IA plus IG, because it is in the box. This current is IK. Simply current KCL is applied. So IK is equal to IA plus IG. Now substituting the various value, what we get? We get IA is equal to alpha 2 IG plus ICB01 plus ICB02. This we get, right? Now it is possible when this alpha 1 plus alpha 2 become unity. Now once it become unity, what happens? This current is infinite. Infinite means, again I am telling you, whenever in the talk I say infinite, infinite का मतलब विशुद्ध रूप से ये है applied voltage divided by load resistance. That is the value of infinite. Clear? The maximum current which can be flow through the thyristor is VDC by R. That's it. So infinite means your thyristor get turn on. Your thyristor get turn on. So when gate current is 0, alpha 1 plus alpha 2 is very less, right? And it is almost you can say equal to ICB01 plus ICB02. But if you keep on increasing the gate current, we know the relation that IC1 is equal to beta 1 IB1, which is equal to beta 1 beta 2 IG. Basic fundamental equation, right? So we can say when you increase gate current, your IC1 increase. Similarly, when IC1 increase, IC2 is also equal to what? Beta 2 times 1 plus beta 1 beta 2 IG. So that is also get increase. Now if IC1 increase, then IC2 increase, eventually what happen? As a base current of this transistor 2 is, base current of this transistor 2 is IC1 plus IG. If you increase this base current, this collector current increase, this collector current ultimately increase this current. Now what happened? An avalanche breakdown occur. Why it is happening? Because that current IB1, that will increase the or you can say with increase in IB1, IC1 is start flowing. Now IC1 start flowing means what? Alpha 1 is increased. Now that current is going to the base current of transistor Q2. So what happened? That IC2 get increased. Now if that IC2 increase, ultimately a regenerative positive feedback effect start, and finally what happened? Alpha 1 plus alpha 2 becomes unity. Once it becomes unity, your thyristor get trigger. Your thyristor get trigger. So this is all about two transistor model of thyristor. How it depend upon the gate current. How it depend upon the gate current. Right? If you keep on increasing the gate current, your device get trigger. Right? So the variation of this alpha, you can see it can go up to unity, right? Because it is the current gain. It depends upon the emitter current. So this is the graph how alpha varies with this emitter current, right? So this is all about the two transistor model of the thyristor, right? So I'm not going to take a huge, long lecture. So I'll stop here, and this is my social media platform IDs like LinkedIn or Power Electronics channel on which you are watching this live. So you can follow me, and in case if you have any doubt, I have also shared my number. It is 9839242490. In case of any problem, you can WhatsApp me. I'll try my level best to clear your doubts. The main motto of this lecture is आपको अच्छे से पावर इलेक्ट्रॉनिक्स समझ में आ जाए. ये रट करके बच्चा सब्जेक्ट क्लियर नहीं होगा. तो आई होप you enjoyed this. Thank you. Bye bye. Take care. Love you.